Hi folks, today we're going to be looking at the TwoSum algorithm and I'm going to show you how exactly you can solve this. We'll look into the two different ways of solving it. There's one that's O(n) squared time and there's another one which is O(n) time. I'm going to focus on the O(n) time at the end. I just want to walk you through the two different solutions so you understand what are the possibilities that you have here. For the TwoSum problem, we're giving a target, which is a positive integer, an array of positive integers, which is nums. The goal is to return the indices of the two numbers from nums that match up to the target. Here is an example. We have a target of 7 and we have an array of nums which is 1, 6 and 13. The result should be 0 and 1 or 1 and 0. 1 and 6 match up to 17, so we're going to return their indices which are respectively 0 and 1. In this second example, we have a target of 9 and we have the nums of 1, 6, 13, 1, 7 and 8. We take the index of 1, which is 0, and the index of 8, which is 5, and we return those back. Very simple. Now let's look at the O(n) square algorithm. To make this O(n) square, we're going to have two loops. The first loop is going to be going through the array normally, just checking every element, and the second loop is going to be looking for a match. We're going to have to go through the vector several times with loop 2 to actually make sure that there is a match for loop 1. To start with, loop 1 points on 0 and loop 2 points at 1, which are 1 and 6. We sum those two together, that gives us a 7, which isn't a match. Next element is 13, so 1 plus 13 is 14, that's not a match. Then we have 1, 1 and 1 is 2, not a match. 1 and 7 is 8, which is not a match. And then finally we have 1 and 8, which is 9, and that is a match. So we take the indices of both of these elements, which are 0 and 5, and then we return that back to the function. Now let's look at the worst case scenario, why this is actually O(n) square. In the O(n) square case, you're going to have the two matching numbers at the end of the array. In this case, 1 and 8 at the end, so that's going to give you approximately O(n) square time. Your actual worst case is when you don't have a match. That means that you have to go through the arrays multiple times with the second loop and you're not going to return any match whatsoever. Now let's look at what it would look like with the O(n) algorithm. So to do this with the O(n) algorithm, we need to make sure we go through the array only once, and we're going to use only one loop for that use case. Now we can use a map which will allow us to look up the elements and their indices much more easily, and that's not going to break our O(n) complexity. In the map itself, we're going to store the element and the index. But to look it up, we need to be smart. So in order to do that, we need to have a difference between the target and the current element that we are looking for. So that is what we're going to be doing the lookup with. If there's 2 inside the map, that means we have a match and we can return both of the indices. Let's walk through the practical example to see how this looks like. So we move the loop to the second element. Now we have 9 minus 6, which is the target minus the element, equals 3. We don't have a match, which means we insert the element and its index into the map. That's 6 and 1. Now if we fast forward to the end, we'll see that at 1, we're going to have a lookup of 9 minus 1, which is going to equal 8. Now we don't have 8 in the map, which means we need to insert the element 1 and the index 4 into the map. However, on the next step, we have target 9 minus the element 8, which is going to equal 1, and we already have 1 in the map, so we do have a match. So at that point, what we do is we take the current index of the loop, which is 5, and the index that we have stored in the map, which is 4. So that's it, folks. It's not that complicated. Now let's look at the algorithm and how to do this in C++. Success. All right, we've done it. Now we can go ahead and submit the solution and check what our metrics look like. So over here we can see we beat, it took us about 6 milliseconds and we beat about 54%. It's not bad. Could be better though. Thank you very much for watching, and I'll see you next time when we are going to tackle another of these LeetCode problems.